Okay, now let's look at the problem number 9. Fish swimming in a horizontal plane has velocity. Initial velocity is given in terms of I and j vector, the coordinates of the velocity. At a point in the ocean where the position relative to the certain rock is initial position is also given in terms of vector. After the fish swims with a constant acceleration for 20 seconds, its velocity is, again, the final velocity is given in terms of 20I minus 5j meter per second. So what are the components of the acceleration of the fish? So we have to find the components of the acceleration, which is ax and ay. Then in part B, we have to find what is the direction of its acceleration with respect to unit vector I. So we have to find the angle where it's directing the acceleration vector. Then we have to find if the fish maintains constant acceleration, where is it at 25 seconds and in what direction it's moving. So we have to find the direction of the velocity vector at 25 seconds. Okay, so let's start now. So first of all, we have to write down what are the values are given. So we know that our v vector initial is given in terms of 4I vector plus 1j vector. Okay, the unit is meter per second. Then we have the initial position, which is 10I vector minus 4j vector in meter. We know the time was 20 seconds. After 20 seconds, the final velocity is given in terms of 20I vector minus 5j vector. The unit is meter per second. Okay, so we have to find what is a ax and what is a ay. Okay, since acceleration is constant, we have to find the components of acceleration. We know that we have a formula, general formula, which is acceleration is equal delta v over delta t. Okay, so we know the time started from 0 and the final time was 20 seconds, so we can just simplify with this formula, delta v divided by just the t. Okay, so let's find first of all ax component, which means we have to consider only x components, with ax is equal delta vx divided by t. Okay, so delta vx means vx final minus vx initial divided by time. That means our ax is equal vx final. So again, we have to consider in this case only x components. Our x final, which is I, so that means 20I minus vx initial was 4. Okay, I have to put the sig fig, but anyway, then divide by 20 seconds, right? So if you do calculation, then for ax you should get okay, just clean up this one. For now you don't need the vectors. Okay, if you do calculation, then you will find that your ax is equal 0.8 meter per second squared. Now let's find ay component. Ay component delta vy divided by t. So here we have to consider now the y components. Okay, so final velocity was minus 5, then initial was plus 1, right? So it means minus 1 divided by time was 20 seconds. So if you do calculation, you should find that your acceleration is minus 0.3 meter per second squared. Okay, now we have to find a direction of the acceleration. Okay, we have to find direction of acceleration. For that one we have to use theta. Okay, so theta is equal inverse tangent AY divided by AX. Okay, so that means theta is equal inverse tangent. Our AY was equal minus 0.3 divided by AX was 0.8. Now if you do calculation, you should find that your theta is minus 20.6 degrees. So if you try to draw the coordinate and see where it is directing, we can approximately draw the coordinate system. Okay, this is AX, this is AY, right? So AX is in the positive, let's say it's this one, then AY is minus 3, so it's something like this one. Okay, so that means our direction of acceleration is pointing in this way, right? If you do calculation, the opposite divided by adjacent, it will give you this angle theta, right? So this theta is equal to minus 20.6 degree, but however we are looking for what is the angle which is starting from the y direction or from x, positive x. So you take all these things up to here, which means if you call this one alpha, so the alpha is 360 degrees minus 20.6 degrees, which should give you, if you do calculation, you should get okay, so if we make it 21, so you should get about 339 degrees from positive x axis. Okay, so now we found part A, part B. Now we have to find part C. In the part C, it says that if the fish maintains constant acceleration, okay, where is at 25 seconds. So let me clean up all those things. Okay, so now we have a time, if it's equal to 25 seconds, we have to find what is direction is it moving. So we have to find the velocity that is moving at 25, after 25, at 25 seconds. Okay, so how can we solve this problem then? First of all, we have to find the velocities, right? We have to find the final velocities at 25 seconds. In order to find that one, what do we need? Okay, so let's find then what is the formula that can be used to find the final velocity in x and in y direction. So we have a general formula, which is v final is equal v initial plus at, correct? Now therefore we can also find our v x final is equal v x initial plus axt. Okay, we have to consider only x component, and to find the v y final, then we have to consider only the y component. So that means for the Vy final is equal Vy initial plus Ayt, correct? Initially, it's given that V initial vector is given in terms of 4I vector plus 1J vector, correct? And time is 25 seconds. So let's find them. First of all, let's find the V. Let's find the. First of all, let's find the Vx one, Vx final. Vx final will be Vx initial is given, which is 4, right? Which is a 4. Then meter per second. So then plus we'll put units at the end, okay? Ax was given, which is we already found it here. Ax is 0.8 and the time is 25 seconds. So if you do calculation, you should find that your Vx final is equal 24 meter per second after or at 25 seconds. Now, what about Vy final? Okay, y component initially is this one, so which means 1 plus acceleration y was found from here, which is minus 0.3 multiplied 25 seconds. So if you do calculation, you will find that it's equal to minus 6.5 meter per second. Okay, now here you can know to which direction it's moving. Okay, the final velocity. Again, you have to use a theta. Theta is equal inverse tangent Vy final divided Vy Vy final divided by Vx final. Okay, that means inverse tangent Vy final was equal to minus 6.5, Vx final was equal to 24. Now if you do calculation, you should get that your theta is minus 15.2 degrees. Okay, you can also draw the coordinate system. The coordinate system, suppose okay your Vx was 24, right? So it's somewhere here, let's say 24. Then your Vy is minus Vy final is minus 6.5. It's something like here. So the resultant one will be drawn here, and this is your theta angle. Okay, this is a V final. So then finally you can say that your V final vector can be given in terms of 24 I vector minus 6.5 J vector. Okay, or you can also find that the magnitude. Okay, the magnitude of the V final is square root of 24 squared plus 6.5 squared. Okay, you can also do such a calculation. You can find what is the magnitude of V final vector. Okay, now you can also do one more thing. You can also find what will be the final position at 25 seconds. Let's do then some calculations. Let me clean up. Okay. In order to find that one, we have to use a general formula, which is x final is basically equal to x initial plus v initial t plus a t squared over 2. This is general formula, but if you want to find the final position at 25 seconds, then you have to find x position or displacement of x. Okay, this is x. Yeah, I think that's you can find it for the x component. Then you can find for the y component. Okay, y final is equal y initial plus this one has to be v initial x, here ax. So here you have to have v initial y t plus a y t squared over 2. Okay, so time is given, so you have to substitute 25 seconds. Ax is given, which is ax is this one, ay is this one, right? Then v initial x is given already in the problem, and v initial y is also given. So if you substitute, plug the numbers, you will find your x final and y final at 25 seconds.